Okay, hello everyone. Today we're going to look at word problems. All right, we're going to solve linear systems of equations using word problems. Now, the key to these is to set them up properly. So we're going to spend some time setting up the word problems, okay? So again, our objective today is to set up and solve three types of linear system word problems. Okay, there's three types we're going to look at. Our essential question, again, we're going to focus on the setup at first. How do we set up a linear system of equations word problem, okay? How do we set it up? Guys, just to review quick, there are three methods that we have covered so far on how to solve word problems. We can do it by graphing, where you graph the two lines and find out where they intersect. Okay, that's the solution, the point they have in common. Or we learn two ways to do it using algebra. All right, if one of the equations is already solved for one of the variables in terms of the other, you can substitute into the other equation and then solve for the first variable and plug it into the other equation and get the other variable. Okay, you can do that. That's substitution. Or you can use elimination, where we get an additive inverse, like negative 2y and positive 2y. So we add these two equations up, we eliminate one of the variables. And then we can solve for one variable, plug it in, and find the other variable, okay? Those are the three methods we've looked at. Today we're going to look at three types of word problems. Linear systems of equations word problems. These are the three types. One is about raising funds. One is about selling tickets. And one is about vans and buses. Okay, they're very similar. And the setups are all very similar. They're just three types that I want you all to learn, okay? Because all word problems, systems of equations, they're kind of set up like this. So let's look at some examples. Example number one, we're looking at raising funds. All right, this is Amy and Elisa. They're a couple of my students when I was at Humboldt. They're selling pies for a school fundraiser. Now, customers, they can buy blueberry pies or blackberry pies. And Amy sold 4 blueberry pies and 14 blackberry pies, and she collected a total of $230. Now, Elisa, she sold 12 blueberry pies and 10 blackberry pies, and she collected a total of $274. Now, the problem here is asking, what's the cost of one blueberry pie and one blackberry pie? All right, that's the problem. All right, the problem is right up here, and I've highlighted a few things. The red is Amy, and the blue is Elisa. All right, X we said is the cost of one blueberry pie, and Y is the cost of one blackberry pie. So it says here 4 blueberry pies. So that's 4x. And 14 blackberry pies, that's 14y. That equals $230. Okay, that's how you set it up. It's relatively simple. All right, Elisa's in the blue. She sold 12 blueberry pies, so that's 12x. And 10 blackberry pies, so that's 10y. You add those two up, her total was $274, okay? Again, once the problem is set up, you guys can just use Desmos to solve it. Or you can use any method you want. Okay, the setup is the key, and that's what we're going to focus on here in this video. Let's look at example number 2. All right, this is about selling tickets. Eduardo goes to a school that Eduardo goes to is selling tickets to a play. Again, the first day, he sells 5 senior citizen tickets and 4 student tickets. Collects a total of $90. Right, the second day, the school took in $80 total by selling 7 senior citizen tickets and 1 student ticket. And they're asking find the price of each ticket. 1 senior citizen and 1 student. Okay? Again, I have highlighted in red. This was the first day of selling, and the blue is the second day of selling. X is the price of a senior citizen ticket. Y is the price of the student ticket. Okay, you guys can set it up like that and just read what it says. 5 senior citizen tickets, that's 5X. Plus 4 student tickets, 4Y. That's a total of $90. Now be careful, this second sentence, it starts with the total. It says the school took in $80 on the second day. That's the total, 80. They sold 7 senior citizen tickets, that's 7X, and 1 student ticket, that's just Y. Again, once it's set up, you can use Desmos or any method you want to solve it. Okay, the setup is what I want you to focus on here in this video. All right, example number 3 is the vans and the buses. Again, this problem, a senior class, it's high school A and high school B. They're going to go to field trips at the amusement park. All right, the senior class at high school A, should be capital T. All right, they rented and filled 3 vans and 12 buses, 630 students. High school B rented and filled 2 vans and 6 buses with 320 students. And they're asked, each van and bus carried the same number of students. They're asking how many students fit in a van and in 1 bus. All right, here's the setup. Again, the red is high school A and the blue is high school B. X is the number of students in a van and Y is the number of students in the bus. So just read it. If high school A filled 3 vans and 12 buses, that's 3X plus 12Y, 630 students. High school B, they filled 2 vans and 6 buses, 320 students. Guys, just make sure that you put the vans with the same variable and buses with the same variable. Make sure that you do that, okay? And once it's set up, you can solve it using Desmos. All right, guys, right now, please fill out the notes assignment and complete the summary. That's in the green folder, which you should be inside right now, watching this video. Again, get prepared for the next Zoom meeting. We're going to go over the vocabulary assignment together, which is in that orange folder. Okay, the vocabulary assignment today, it asks to match the type of problem with the best method to use. Okay, a little different today. And guys, this is not the answer in the notes assignment. The notes assignment talks about with 3 types. Right there. Make sure you know that for the notes assignment. Okay, that's it. Thanks.